There are moments when a simple observation can shake our deepest certainties. Federico Faggin experienced one of those moments while watching a documentary. On the screen, a unicellular organism, a paramecium, was gliding through water with an elegance that seemed almost conscious. It swam with ease, dodged obstacles, explored its surroundings with curiosity, and moved as if guided by some inner intelligence, more like a small fish than a speck of microscopic life. That tiny being, barely visible to the human eye, did more than move. It behaved as if it knew what it was doing. It had no eyes, no brain, no nervous system, and yet it acted as though it could see, decide, and respond with intention. This scene ignited in Faggin a lifelong question. How can something so small, without neurons or synapses, display behavior that challenges even our most advanced technologies? Francis Crick, one of the discoverers of DNA, once remarked, "Biology is the study of complicated things that give the appearance of having been designed for a purpose." That reflection resonates powerfully here. The paramecium is not only complex, it is autonomous. It seeks food, avoids threats, reproduces on its own, and does so without any external programmer pulling the strings. Its behavior does not depend on a loaded software package, but rather on an intelligence that seems to flow from its very structure of life. Placed next to this creature, our computers appear fragile. However powerful they may be, they remain closed systems. They can only act within the boundaries of instructions given to them. They require precise parameters, defined goals, and pre-programmed conditions. When those parameters change, they crash, freeze, or wait inert. The paramecium, by contrast, adapts. It improvises. It survives. Over 2,000 years ago, Heraclitus captured this idea in a phrase that has echoed through philosophy. Panta, everything flows. Life is not an object to be dissected or frozen. It is a continuous process, a perpetual stream that cannot be reduced to static parts. Living beings are open systems that exchange matter, energy, and information with their environment. Unlike robots, they are not assembled from outside. They build themselves from within, following a logic that is neither linear nor predictable. In this sense, even the smallest creatures are not trivial curiosities, but living demonstrations of principles that challenge our assumptions. They embody a type of wisdom that is not taught, but lived, flowing through every vibration of their being. This flow of life means that even the simplest organisms display remarkable elasticity in responding to their environment. The paramecium does not repeat actions mechanically. It reacts to changing conditions with something that resembles a primitive discernment, a choice made in the moment. Now, imagine a future where technology has advanced to the point of creating robots capable of assembling themselves, replicating their components, adjusting their structure when needed. Would that count as life? Faggin would say no, because life is not defined merely by form or function. It carries a subtler essence, inner experience, intention, and a unity that feels and decides from within. A living cell divides not because an external hand instructs it, but because within it lies an implicit knowledge, a direction that emerges spontaneously. That is what separates it from any machine. No computer can generate, purely from itself, another identical machine without external intervention. No robot can improvise life. The true complexity of a cell is not found only in its biochemical components, but in the way those components interact in real time, reorganizing themselves to meet shifting contexts. This self-organization, constantly adapting, is what allows life to sustain itself in an unpredictable world. It is as though every molecule participates in a conversation, each adjustment feeding into the whole. creating a harmony that cannot be reduced to isolated parts. Machines may mimic fragments of this, but they cannot reproduce the living dialogue itself. Reverse engineering, no matter how brilliant, can only copy structures. It cannot reproduce the inner spark of consciousness. Even when we simulate some behaviors of living organisms, we remain blind to what truly animates them. In this sense, the paramecium becomes more than a biological curiosity. It is a mirror that reflects the limits of our understanding. Within its tiny movements lies a mystery that humbles the pride of our machines. And perhaps this is the lesson Faggin wants us to hold on to. That mystery is not only found in the vastness of the cosmos. We do not need distant galaxies to feel awe. It is enough to look into a drop of water through the lens of a microscope and give a few minutes of deep attention. In that microscopic stage, life performs its most astonishing theatre, reminding us that what we call intelligence, adaptation, even purpose, might begin at a level far smaller and far older than our own species. At the heart of every living being beats a truth that science has overlooked for far too long. Life is not a machine. It cannot be reduced to molecular gears or simplified into biochemical reactions. Federico Faggin insists that living organisms are holistic systems, not mere collections of parts. What defines them is not the sum of components, but a dynamic unity that organizes itself from the inside out. Reductionism has tried to convince us that to understand atoms is to understand human beings. But if that were true, then a mere list of ingredients would be enough to explain the taste of a recipe. Life, like art, only manifests itself in its integrated totality. Carl Sagan captured this beautifully in a phrase that still resonates in contemporary biology. You are made of 100 trillion cells. Each one of us is, in fact, a multitude. We are not a single thing. We are an organized symphony, an intricate weaving of processes and memories communicating with one another in astonishing coherence. A cell does not merely react, it interprets. It does not merely execute instructions, it decides. For Faggin, this point is essential. Cells, especially eukaryotic cells, contain a structure so sophisticated that it cannot be explained by chance alone, nor by the simple accumulation of random mutations. With approximately 10 to the power of 14 atoms, a cell possesses an architecture capable of sustaining symbolic processes, not just physical interactions. Inside it, something more than chemistry takes place. Meaning itself emerges. In living organisms, information is not neutral. It is alive, contextual, symbolic. A chemical signal does not carry a universal meaning. Its effect depends on the internal state of the organism that receives it, on its history, and on its immediate environment. This interpretative capacity is what distinguishes life. By contrast, a computer processes symbols without ever comprehending them. To the machine, data carries no context, no intention. It adds, sorts, and filters, but it does not feel, it does not know. The code it runs does not mean anything to it. A cell, however, can alter its behavior if it perceives a threat, adjust its metabolic pathways if a nutrient becomes scarce, or even communicate with other cells to coordinate collective responses. One striking example can be seen in bacteria. When exposed to antibiotics, some species exchange fragments of DNA with others, sharing resistance and survival strategies. This adaptation is not programmed from outside. It emerges from the symbolic interaction of the system itself. Faggin proposes that the processing of information in living beings is intrinsically linked to consciousness. Not consciousness in the human sense, but an organizing principle that allows each cell to maintain an internal direction, a vital tendency guiding its actions. It is not artificial intelligence, but biological intelligence, alive, embodied, situated in context. The so-called junk information within DNA, long dismissed as useless, may in fact hold precisely the symbolic instructions that defy a mechanical reading. These sequences are not technical data, but living patterns, expressions of meaning that we do not yet know how to decipher. By ignoring this symbolic dimension, science has often blinded itself to the obvious. Living beings do not operate as machines, but as systems of meaning. Each cell is a small universe of decisions, a conscious network that not only executes functions, but actively participates in shaping its own destiny. This vision transforms biology into something closer to philosophy, a science of meaning rather than a catalogue of mechanisms. To look at life in this way is to recognize that what animates a cell is not a cold algorithm, but an inner impulse to sustain itself, to persist, to grow. In this light, even the most basic organisms reveal themselves as participants in a grander symphony of existence. They do not simply exist. They contribute, respond, and adapt, weaving their part into the collective harmony of life. This is why Faggin argues that we must abandon the illusion of the machine and begin to see ourselves as expressions of a deeper symbolic order. Life did not evolve as a bloody struggle among individuals. It evolved as a symphony of collaborations, symbiotic exchanges, and shared strategies aimed at sustaining the whole. Federico Faggin invites us to leave behind the narrative of Darwinian competition as the sole evolutionary force, and to look anew at how nature creates and preserves life. A fundamental example is that of cyanobacteria, microscopic organisms that billions of years ago began to perform photosynthesis. By transforming carbon dioxide into oxygen, they created the breathable environment that would eventually make complex life forms possible. They did not act out of individual self-interest, but as part of an emergent design in which molecular cooperation became planetary architecture. The atmosphere, the oceans, the forests, the food chains, all obey a delicate network of ecological layers that regulate one another. When carbon dioxide levels rise, certain plants proliferate. When oxygen grows scarce, other species respond. Life is constantly balancing itself, like a breathing organism. This principle was embodied in the Gaia hypothesis, proposed by James Lovelock, and further developed by Lynn Margulis. The Earth is not a passive stage, but a living being that self-regulates. For Faggin, this vision is transformative. It reminds us that human beings are not masters of the Earth, but cells within its body. Every human action reverberates throughout the entire organism. To ignore that connection is like the liver believing it can survive without the heart. Johann Wolfgang von Goethe intuited this truth with his poetic sensitivity when he said, "Life is an inexplicable magic." That magic is not found in extremes, but in relationships, in the way each part sustains the whole. Ecosystems are much more than mere accumulations of species. They are conscious systems, woven out of feedback, communication, and collective memory. The tragedy is that, at some point, we lost that awareness. The Industrial Revolution disconnected us from the Earth. We replaced the wisdom of the forest with the efficiency of the factory. We cut down forests, polluted oceans, and altered climates. And today, as Antonio Guterres has warned, we are on the edge of the abyss. This is not merely about environmental sustainability. It is about understanding that by harming the ecosystem, we are harming a living network of which we ourselves are part. Astronaut Luca Parmitano expressed it with striking clarity It is mankind that is at risk, not the Earth. And Pope Francis reaffirmed it in simple, direct words. We are not separate from other creatures. The consequences of our disconnection can be seen in episodes such as the uncontrolled growth of algae that devastates entire marine ecosystems. Life, when unbalanced, also collapses. Elton Krenak, the indigenous thinker, reminds us, the Earth is part of our memory. If we forget that, we forget ourselves. Isaac Bashevis Singer, with his compassionate gaze, once wrote, "The only hope for mankind is love. Love that is not mere emotion, but recognition of interdependence. Love as the organizing principle of life." Eric Fromm once asked a question that still lingers. Will we be able to live here in 100 years? The answer does not depend on technology nor on material progress, but on our capacity to remember that we dwell within a living being, a being that, if we listen, still has much to teach us. Seen in this way, Gaia is not just a metaphor but a scientific and spiritual truth. It calls us to humility, reminding us that our civilization is no more than one chapter in a much larger story. The real challenge is not to dominate the Earth, but to enter into dialogue with it, to hear its rhythms, respect its limits, and participate in its renewal. The path forward lies in cooperation, not conquest. By reawakening the memory of our place within the Earth's body, we may rediscover that the secret of survival is the same today as it was for cyanobacteria billions of years ago. Life thrives not in isolation, but in communion. For centuries, humanity has divided the world into the living and the inert, as if there were a definitive line between a cell and a stone. Federico Faggin invites us to blur that boundary, not because everything is alive in the same sense, but because the radical distinction between animated and inanimate matter collapses under the light of quantum physics. The mechanistic vision of the 17th century taught us to see organisms as complex machines, composed of smaller parts that operated in predictable ways. Yet when we descend to the subatomic level, we discover that matter is not what it seems. Particles are not solid spheres, nor fixed building blocks. Leon Max Liederman, Nobel-winning physicist, put it plainly. Particles are not objects, but localized vibrations in the quantum field. In other words, what we call matter is woven from fluctuations, energetic patterns that arise and vanish. Even the simplest atom participates in an invisible choreography where everything is in relation with everything else. This vision redefines our notion of life. If the foundation of reality is vibration and interconnection, then the living cannot be an exception in a dead world. The difference between a molecule in a living cell and the same molecule in a rock is not one of essence, but of organization. Faggin argues that living organisms are not merely complex systems, but quantum classical hybrids, capable of operating across both domains. In photosynthesis, for example, plants transfer energy with an efficiency impossible under classical physics. Today, we know this process relies on quantum coherence, in which a particle simultaneously explores multiple pathways before selecting the most effective. The same applies to certain migratory birds, which orient themselves using biological sensors sensitive to quantum entanglement. Life, at its deepest level, does not ignore the quantum realm. It incorporates it. Albert Einstein once remarked, "The most incomprehensible thing about the universe is its comprehensibility." This paradox becomes tangible in living organisms, capable of maintaining coherence, adapting, and reproducing, not because they obey an external design, but because they express from within an organization that integrates seemingly contradictory levels of reality. Here, the quantum field takes center stage. It is not a static background from which particles emerge, but a dynamic sea of possibilities, a restless medium where potentialities surge and collapse into temporary configurations. Life exploits this fundamental plasticity to build systems that regenerate, self-organize, and transform. This means that life is not a passive byproduct of physical laws, but an active participant in the quantum field. It draws upon the field's fluctuations, shaping local realities through collective coherence. A cell, for instance, does not simply obey external constraints. It resonates with quantum rhythms, amplifying certain possibilities while suppressing others, guiding matter into living order. In this sense, living beings are not outside physics. They may be its most sophisticated expression. They do not break quantum laws. They utilize them to sustain processes classical physics cannot explain. To recognize this opens a doorway to a more unified vision of existence, where life is not an improbable anomaly, but the natural unfolding of a profoundly connected universe. The frontier between the living and the inert is not a line, but a spectrum, a continuum in which life emerges as the most conscious expression of a cosmic dance that never ceases. And perhaps this is the greatest lesson, that every living system, from the humblest bacterium to the human mind, carries within it a whisper of the field itself. To be alive is to be in dialogue with the quantum sea, drawing meaning and direction from its endless waves. What Faggin urges us to see is that this dance is not abstract. It unfolds here and now, in every cell and every breath. When we look at life through this lens, we no longer ask whether matter is alive or dead. We begin to perceive that all matter hums with potential, and life is the song that emerges when coherence aligns with intention. Life is not merely organized matter, it is information that interprets itself. Federico Faggin insists that to truly understand what is alive, we must abandon the idea that organisms are computational devices. A cell does not act through binary commands. It recognizes signals, evaluates them, and responds with meaning. In biology, information is not technical but symbolic. A signal on its own is never enough. Its effect depends on context, on the history of the cell, and on its interactions with the environment. Life does not simply respond, it understands. This kind of understanding demands far more than algorithms. It requires a hierarchical network where different levels, from the quantum to the physiological, feed back into one another in real time. Quantum coherence allows certain processes to occur simultaneously along multiple possible pathways, as in photosynthesis. Yet this coherence does not vanish as systems scale up. It transforms into symbolic coherence, where every action makes sense within a wider whole. Consider a cell encountering a threat. It does not merely run a defensive routine. It decides how and when to respond, based on contextual information. Such behavior cannot be fully explained by isolated physical or chemical laws. It is a dance of meaning, where multiple interpretive factors converge. The immune system provides a striking example. It does not merely detect pathogens, it learns from them, remembers them, adapts its responses, and cooperates with other cells to act collectively. This is not a technical system, but a symbolic one. Here a deeper dimension arises: the collective behavior of the particles within a cell. Every protein, every ion, every molecule vibrates in coordinated patterns, as though part of an invisible concert. This quantum self-organization allows the cell to be more than the sum of its parts. It is not a collection of isolated pieces, but a dynamic interplay of relationships that generate order and meaning. Faggin observes that this living intelligence cannot be replicated by artificial intelligence. AI processes structured data. Life processes meaning. And meaning is never imposed from the outside. It emerges from within the living web itself. Within this context, DNA is not a fixed manual, but a network of symbols that activate depending on the environment. Genetic information is not a static code, but a dynamic language that interprets, reinvents, and adapts. Life, then, is not a set of programmed responses, but a symphony of interpretations, a network of meanings renewed at every moment. To comprehend it, we must abandon the logic of external control and step into the mystery of that which lives from within. In this light, each living system is not a passive receiver, but an active interpreter, constantly weaving significance out of signals. What seems mechanical from the outside is, in truth, an unfolding dialogue of matter and meaning. What makes this perspective radical is the shift it demands in us as observers. Machines obey, repeat, and simulate, but life interprets, improvises, and creates. In recognizing this, we are invited to see that even the simplest cell embodies a depth of intelligence that remains far beyond our best technologies. For mechanistic science, life is nothing but an accident, and death merely a failure or malfunction. Federico Faggin urges us to look more closely. Death is not the final act, but rather a strategy of extraordinary biological intelligence. At the very heart of living organisms lies a programming that allows them to die at the right moment. This phenomenon is called apoptosis, or programmed cell death. Cells know when they must step aside for the organism to function better. They do not die by default, but by decision. They withdraw from the system like a musician leaving the stage so that the symphony may continue. The purpose here is not external, but intrinsic to life itself. Faggin sees in this a powerful signal. Living organisms act with intention, not because someone is pulling strings from outside, but because they participate in an inner web of meaning that guides their actions. Such behavior cannot be explained by algorithms or deterministic mechanisms alone. The cell is not merely executing a fixed protocol. It responds with wisdom to the moment and the whole. An immune cell, after fulfilling its duty, may self-destruct to preserve balance. It is not a machine serving an imposed end, but a being that somehow understands when to act and when to stop. This phenomenon is just one of many hints that life at its essence organizes itself not by computational logic, but through a spontaneous intelligence oriented towards the common good. Machines, by contrast, do not know when to stop. They continue their programming until something switches them off. They lack awareness of the whole and possess no capacity for sacrifice. That is why Faggin insists that life cannot be reduced to technical functions. It carries a symbolic, subjective, and above all, loving dimension. Teilhard de Chardin expressed this with striking clarity. Love is the structure of the universe. Faggin reclaims this vision, linking it to cooperation as the true principle of evolution. Cells cooperate, species co-evolve. Life flourishes when it connects, when it integrates, when it recognizes itself in the other. In forests, the roots of trees communicate through fungal networks known as mycorrhizae, which enable the exchange of nutrients and chemical signals. They do not compete, they collaborate, they look after one another. This form of silent cooperation is love translated into structure. Without it, many ecosystems would collapse. Interdependence is stronger than domination. Modern biology increasingly confirms that such cooperative behaviors are not exceptions, but the rule of life. Even bacteria, often imagined as primitive and selfish, form vast colonies where they share resources and information through chemical signaling known as quorum sensing. These microbial communities demonstrate that even at the smallest scale, survival depends on communication and mutual support. Far from being blind automatons, these organisms embody the same principle of interconnection that Faggin highlights in higher forms of life. And yet, many scientists still repeat, as Francis Crick once did, that life has no purpose or meaning. But that vision, Faggin argues, is blind to the inner workings of life itself. What seems directionless from the outside reveals a profound order from within. Life does not merely function, it knows why it functions. To understand life as a network of purpose and compassion reshapes not only our biology, but also our ethics. It calls us to act not from control, but from care. Love, death, and purpose are not poetic metaphors, but real biological strategies. They are the invisible threads through which life renews itself, sustains itself, and weaves its connections. They remind us that existence is not only about survival, but about participation in a larger harmony, a dialogue between individuality and the whole. Recognizing this may be the first step toward a new science, and perhaps a new civilization. There was a time when biology tried to explain life as if it were nothing more than a computer program. Genes were lines of code. Cells were processors. Organisms were biological machines. But Federico Faggin argues that this metaphor has reached its limit. Life is not software running on hardware. It is an indivisible whole, dynamic and imbued with its own meaning. A cell does not require an external programmer. It builds itself, organizes itself, repairs itself, and, when necessary, it even self-destructs. All from within. By contrast, a machine exists only if someone else designs it, assembles it, and maintains it. The living system is autonomous, the artificial system dependent. What appears to be a technical difference is, in fact, a profoundly philosophical one. In living organisms, there is no separation between the one who acts and the act itself. There is no user and program. Everything is woven together into a web that flows with purpose. A cell does not simply obey, it decides. Life does not follow commands, it interprets. This act of interpretation is crucial. It suggests that living beings are not passive mechanisms, but active participants in reality itself. Each cell, no matter how small, carries within it a spark of subjectivity, a trace of awareness that machines fundamentally lack. Faggin insists that the computational paradigm cannot grasp this dimension. No matter how far artificial intelligence progresses, it will never feel hunger, desire, fear, or love. Because AI has no inner world. It has no I that can give meaning to its operations. It can simulate emotion, but it can never live it. Life, by contrast, is born with meaning. From the tiniest bacterium to the human being, every form of life carries an inner direction, an intention. This intention is not imposed from the outside. It arises from the very structure of being. Machines can achieve astonishing feats, but they remain dependent on external design. Living systems, however, embody autonomy. They are capable of generating novelty, of responding creatively to uncertainty. This difference is subtle yet decisive, for it marks the boundary between imitation and true life. The problem lies in the fact that we continue to use inadequate conceptual tools. It is like trying to measure a song with a ruler. That is why Faggin calls for a new paradigm, a science that recognizes consciousness, subjectivity, and meaning as fundamental aspects of reality. To illustrate this limitation, Faggin recalls a famous paradox. According to classical aerodynamics, the bumblebee should not be able to fly. Its body is far too heavy for its small wings, and yet it flies. Not because it breaks the laws of physics, but because our understanding of those laws was incomplete. So it is with life. Organisms are not magical. Our theories are simply insufficient to capture them. Life soars, while our models drag it down to the ground. It is time to let go of the old maps and dare to look at the territory with new eyes. For life is not an algorithm. It is an embodied mystery. And that concludes our video. If you enjoyed the content as much as we did, don't forget to subscribe so you don't miss a single episode. Leave a comment below. We'd love to hear your feedback and suggestions for future videos. And don't forget to turn on notifications to stay up to date with all our updates. Thanks for being part of our community. See you in the next video.